Hey guys, hope you had a good break and are ready to get back to a little Python code. And today we're going to talk about functions. Functions are pretty important. A function is a block of code, and it's just like a custom block from Snap. And we'll take a look at one of those in just a second. And it's a way to separate the different concerns in your code. So if you're doing something complicated, you don't want to see a giant, uh, you know, file that's got all of your Python code in it. It's tough to follow. You want to be able to break it up into different parts and to have each one of those parts farmed out to just like we did with the custom blocks in Snap. Um, all your code that you use in the functions should be things that are reusable. You should be separated out to keep yourself dry. If you remember that from last semester, dry is don't repeat yourself. And anytime you use something more than once, you should consider putting it into something like a function. So for instance, let's just say I have a really hard time spelling the word convenience. So here we've got, you don't have to use the windshield cleaners and paper towels at the gas stations. They're just for convenience. Don't feel like you're being an inconvenience if you don't use them. So I've misspelled convenience a couple of times. And when I print it out, I don't want to have to go look it up every time either. So one thing could do is to define essentially a custom block, the same way again we did at Snap. If you remember here, I've got pick random from 0 to 3 and say it for 1 second. I can click this and it's going to say one random, it's going to do another random. There's a third and a fourth. It looks like I picked one both times for the at the end. But one of the things we have here is I've got my own block that does exactly the same as the pick random block. If this were more complicated than what we have, here I've got just a wrapper around picking random. If we want to do something really complicated in here, we could, and that way it wouldn't clutter up our main source. We'd be able to just drop in a custom block and it keeps things nice and pretty. So if something was complex, we can move it to here and have it out of the way of our normal code. So that's what I'm doing here. I'm going to define, that's what the def is, space, function name. In this case, I don't have any parameters. If you remember in our snap function, we had 2, so we could feed them into the pick random, so between 0 and 3. But here I don't have any functions. I just want to return that word that I can't spell, which in this case is convenience. So this time when I print it out, instead of having to look up the word each time, I'm just going to call that word. And then I know I'm going to get convenience spelled right each time. So then when I run it, I've cheated, I've already run. But you can tell that it pops up the first time, shows them wrong, pops up the second time, and we've got exactly what we were looking for. Okay, so that's all a function is. A function is a way of taking out code that you can use more than once and make it so it's easy to read and so you don't write the code. For instance, if I had 2 different functions that were doing this, I might have it misspelled once and then misspelled it in a different way, a different place. If I tried to fix it in one place, it wouldn't fix it in other places. So we want to use this function every time we reuse things. So let's look at our do now. Our do now this time is actually pretty simple. Type the following code. And we all know you never type the following code. You copy and paste it and you put it into Repl.it. So let's see what we've got. This is what we're going to be doing, right? We just import random, print, and I've already got that in here with some stuff. Here are the words that we're supposed to learn. We're supposed to learn what a function is. We've already learned what a function is. It's a piece of reusable code that you separate out and you give a name, and it's just like a custom block in Snap. Arguments are the things that we send to the function. So remember in Snap, if I wanted to send for my random for this block right here, we just have 2 different, we've got the A parameter and we've got the B parameter. And we're doing something similar when we're doing it in Python as well. Calling it is when you call the function by name and you make it run. Importing is something new. So importing is, we've been calling a lot, like the print function is actually a function. So print is a function that's in Python. This one that we're going to use this time is going to be in the library random. We're going to try to get a random integer the same way we were doing with the pick random in Snap. So this pick random, we're going to do the same thing using an imported function in Python. And the last thing is returning. That's the value you get back. So in here, when we had our function, that report, the block, it sends back what the value of the function is. The same thing here. That's what is being returned. So here we are. We're going to call it. This is the same thing that's happening twice. This is calling the function. The function that we're actually calling is randint, so random integer. 0 and 3 are the arguments. We'll figure out what that does in just a second. If I try to run it right now, it should blow up. There we go. So it blew up on us. The reason why is because we want to get this random int function out of the random library. To be able to access the random library, not a core function, but a library function, we want to be able to put in the import statement so that we let Python know, hey, we're not only using core functions here, we're going to use things that are in random as well. Now it should be happy. Let's see if it's happy. There we go. So one of the things that's important to notice is that here, when we call the function, we're not getting an output. We've got 3 outputs here, and we've called the function 1, 2, 3, 4, 5 times. So why is that? And it's because we haven't printed it. So the print function is takes the call to the randint function, and here we've got, it looks like we're getting between 0 and 3, the same way we did over here in snap when we called the pick random. And now we're going to print it to the screen. So we've only printed 3 things, and we print the value that's returned from the function. Function's called, it's got 2 parameters, it's got 0 and 3 each time, and then we can see what happens when it's returned. Let's change a few of these. So let's change 5 to 10, and let's do this one, -15 to -10, and let's see how that happens. So 1 is between 0 and 3, 8 is between 5 and 10, and -13 is between -15 and -10. So what does randint do? This is one of the things that the do now wanted us to figure out. And it looks like it gives us a random number that's between the integers. They're taking n as parameters. And so sure enough, that seems to work so far. What do the values 0 and 3 do? So we've changed the numbers here, but let's go ahead and do some more things. Let's see exactly what I chose to do in here. Here there's 2 different randoms, and we say A, we're assigning to one random between 1 and 4. B, we're assigning another random between 6 and 10. Then we're going to print out the I, and we're going to print out, so this is just like a loop that we did in snap, and we can run it and see lots of different options. So I'm going to go ahead and make, oops, don't do that. So I'm going to go up here and comment these out so we don't print those first 3, and we can just run into loops, and let's see what it does here. So sure enough, we've got 1, we've got A, we've got B, we've got string random between A and B. Now we're getting super complicated. We probably should have printed out what those are too. I almost feel like restarting the video. I'm not sure why I thought that would be a smart thing to do, but you see what we're doing. We're changing between here and there. Let's go ahead and print that out. Print A. Let's remember, if we want to print it out as a string, since int, we're going to have to cast it. That's what I was talking about in the last video, is the first number. Let's print string value of B is the second number. And then the last thing we're going to do in the loop is print out a value in between those 2. Remember that in the for, or when we're doing the define in our original function, the thing that's important to remember is that white space is what tells it what block we're in. So just a quick review. If you can tell usually when you see this colon, something like this is going to happen. This is the function. The function ends right here because the white space is ended, right? So if print were like this, it would be part of the function. But since it's all the way to the left, we know it's not. So the same deal over here. We've got a for loop, and everything that's here that's spaced over is part of that for loop. Let's run this. This might be a little more useful to look at. And we've got 4 is the first number, 9 is the second number, and we've got something that should be between the 2 of those, right? So so 3 is the first number. Some idiot didn't put a space in between, so it looks really messy. 10 is the second number. 7, sure enough, in our first iteration is between 3 and 10. 1 and 10, 7, 4 and 8. 8 is up the high. 4 and 9. Does that make sense? So let's try to see how we can screw things up to make sure that we understand the way that works. We think we've got ints between here, 1 and 5, and that sure enough seems to be how it comes out. But let's try to break it to see if we can, we know for sure how it works. So let me go get rid of these prints so that they won't get in our way. And let's print a random int between 10 and 1. Now there shouldn't be any numbers between 10 and 1 if we expect the first one to be lower. Let's see if we can still figure it out. No, it blew up. Okay, so that's bad, obviously. Still printing out some stuff. I'm not sure where that's coming from. But if you notice, it's blowing up. It's tracing back, and it says, we've got an error. And that's because the 10 is bigger than the 1, and the smaller number needs to come first. Let's change it to -10 and see what sort of values we get. So -10 happens first. Print this one. Don't print this anymore. Not sure what's going on there. Begin. Why are you doing 3 as the first number still? You're killing me, Smalls. This is all we should be doing now. Run, Smalls. Smalls. Begin. Perfect. Thank you, Smalls. So we've got to print a random number, and this time -6 is between -10 and 1, right? So we figured out essentially what's going on. Let's run it again. There's -5. Do we ever get anything bigger than 1? Doesn't look like it. So it's not 1 away from 10, right? That's one way it could have interpreted that. But we've seen things that are bigger than -9, so we know that's not exactly what's going on. So there you go. So again, when we did the first version, which was from 10 to 1, we knew that was wrong, and we got that error there. And we know that it's a range between the lower number that's first and the larger number that's second. So what's the difference between, this is part of the do now, the random randint and print random randint? So what's the difference between this one and that one? We've already seen that essentially. This calls it, but it only calls it. Calls only. So it doesn't do anything with the result. If we just run that, nothing will get printed out. That's pretty boring. If we take this out and we comment that one, now we're printing what happens from the call. And of course, because I still left the question mark in there, it blew up. Welcome to the world of programming. Here we go. Okay, cool. So the random library's randint function is a function that returns an integer value. Adding the print puts it on the screen, and not having the print means we've just got a call. That's it. Okay, so let's move on to today's assignment. Today's assignment in the lab is to write a program that simulates a magic 8-ball. And if you've ever messed with one of these, you know you can ask it any question you want. I think you're supposed to knock it once before you ask a new question so it forgets your last question. You tip it over, and then there are lots of these values that can pop up. If I remember, it seems like there's like a dodecahedron or whatever. It's a 20-sided face. And it'll pop up and show you what's in an answer to a yes-no question. So here's one value, as I see it, yes. So essentially we want to create a program that can tell the future, right? You ask it a question and it can tell you, and we want it to have one of these responses. Now, there are actually a ton more responses. There's a video down here if you wanted to watch it, and I'll probably put the link in with mine, I'm not sure. And he's went through and figured out every answer there is in the 8-ball. Let's see where he shows it. Somewhere around here. There's the 8-ball, and they're all 20 answers, and I don't remember where he says it. This video is much worse than my first. Ignore that. There's a nice commercial. Regardless, there are 20 different, and he sets it up like this. This is a real pain. And here are all our different potential answers. For us, we only need these 1, 2, 3, 4, 5, 6, 7, 8. Okay? I'm not going to do this assignment for you, but I'm going to do one that's a lot like it if you follow closely. I'm going to flip a coin, okay? And I'm going to make a function that helps tell me what the coin flip value is. I'm also going to, within the function, call a function. And the function is going to be from the random library. We're going to call the randint function that we had just a second ago. So we're going to get a random integer, and we're going to use that to determine a coin flip. So let's go ahead and clear that. We're going to flip a coin. Let's ask a user to flip a coin, then we'll emulate a coin flip with the random library. And let's make that because I'm a little OCD about my comments. And if we wanted to read everything there is to read about the random library, we'll see that it has a lot more functions than just randint. And if you ever get bored, you can come check out different things that you could be using to get random numbers. One thing that is interesting to point out, making random numbers is hard. One easy way might be to take what time it is and take the thousandths, of the second, and take that to use some sort of random. If you wanted to get a random number between 0 and 1, you could take the hundredth of a second and just pop that out. But that's not really random, right? I mean, that's based on time. So to have real random numbers is a complicated procedure. And here we have pseudo-random numbers are coming out of the random library. If you wanted truly random numbers that nobody could figure out how you're getting them, you have to be a lot more careful. And that's where we have the secrets module. And that might be something fun to watch. if you were really into programming and you wanted to figure out how to hack things, and you could figure out that someone was using just the random library to come up with passcodes or something, you could actually reverse engineer how the random library works and get those numbers based on whatever it is they're using to seed the numbers. And you can read a little bit about seeding here. But basically what they're saying is the algorithm for the random numbers isn't truly random and is crackable in a security context. But we don't really care for the purposes of this coin flip. We are not trying to break into the Pentagon here. We're just trying to say whether something's heads or tails. One thing that our book would like for you to do is anytime you write a function of your own, and we're going to talk more about this in 3.2 or 3.02 in the next lesson, they want you to give it a name, a purpose, describe the arguments, and describe what it returns. And you're going to put this all into a comment. And this is, just a big comment. I've used the triple double quotes, so I guess lots of quotes, right? So I can do it in a block. And this is the way that they like for you to form it. So the function I'm going to write, again, I've imported random. Remember, if you don't import the library, you can't call the functions that live in it. The only functions that you can call without importing a library are the core functions we've been using up to this point. Here, I'm making defining my function coin flip. The purpose is to return the value of a coin flip. No arguments. So coin flip, there's the name. No arguments right there. There are two different outcomes. Now, this is where I'm going to get a little cleverer than the fellow that's writing this junk for you, because you can tell he's doing it about 1 billion times, and then the back end of this is he's going to have 1.5 million if statements, okay? And that's just horrible, horrible code that makes my eyes scream, okay? Remember when I was talking about don't repeat yourself? Good heavens, man. So let's look at a trick out. I'm going to set up all the different possible outcomes. In the case of a coin flip, there are only two, heads and tails. So my flip is going to be a random flip, and it can either be heads or tails. I've only got two values. And here I'm going to start at 0, and it can be 0 or 1. So it's either 0 or 1 coming back. I'm going to print what it is just so that we can debug right now. If I was releasing this to the wild, I probably would comment that out. And then we're going to return the outcome that belongs to that flip. Remember, outcomes, this is the first array value, or the first member of the array, so it is of index 0. Tails is the second part of the array, its index is 1. We're going to have 0 or 1. So when we get flip, we're going to be able to map it, right? So that's clever. Might be too clever, but that's a much nicer way of, I don't know what just happened. That's a much nicer way of writing this code very concisely. So let's ask the user to call a flip. Call is going to be determined by what the user types in. It should be heads or tails. If they don't, they're always going to miss it. We'll see that in the logic in just a second. I've got a new line just to make it prettier. If I don't have this, we can see what that looks like. Call it heads or tails, and it's right here at the end. All right, so that's not pretty. So I'm going to sit here and I'm going to add a new line so it's just a little bit prettier. So I'm going to call heads or tails to make Jerome Bettis happy. If you remember that Super Bowl, we're going to say what the call is. Then we're going to actually do the flip after we've established what the call is. We're going to announce what the call was, and then we're going to say whether someone got it or not. So the only other important thing to put in here is the comparison I'm doing here is case insensitive, okay? Remember that tails versus tails, I think, I actually haven't tried this. Let's see if we can do it without being case insensitive and see if it works. So let's do the flip, which is going to be heads or tails, and let's do the call and see if they match. This could be interesting. So heads, we're doing in title case. That's what it's called if the very first letter is capitalized and the rest aren't, and tails as well. So I'm going to call tails all lowercase. Call is tails. The flip is heads. You don't got it. Let's do it again. Tails. You don't got it. So even though I guessed tails, and the call says it's tails, and the flip is tails, it tells me I missed. The reason why it tells me I missed is because I did all lowercase tails, and this comes back with an uppercase. The way to make sure in here what we're comparing is that it's exactly the same. Let's get rid of that. I'm going to make it lowercase in both cases. I'm going to take the flip value and the call value, and I'm going to make them both lowercase and check. So now I'm case insensitive. one of the neat tricks I did here is the call is, no matter what you type in, it's going to use title casing to print it. So again, title casing is when you capitalize the first letter. So call it heads or tails. Heads. Call it heads. The flip is heads. You got it. And remember, we're printing this out right now so we can double check. Heads is the 0th member of the array, and tails is the first. So I printed out that it was 0. That means that heads is being returned from my array here. And then we compare it to what I typed in, which is heads, but I make it all lowercase in the comparison. The flip is all lowercase, the call is all lowercase, and we know that heads is heads, and we got it. How would I take this? And hopefully this all makes sense, right? So at the end, I would probably take the flip out. So we don't have that weird 0. Okay, tails. Call is tails, flip is heads, you ain't got it. Oops. Try it again. So now, even though I have weird casing, it still has it. Now notice I can do anything I want, but you're always not going to got it, okay? Anything I want, if it's not heads or tails, it's always going to fail. Now, the thing to remember is, how would I change this into something for my 8-ball? Well, you're just going to have more outcomes. So how would you change how many outcomes come out? And then how would you change what the strings are for each of those outcomes? And if you see what I'm doing here and you extrapolate it, you've got your 8-ball all the way ready to go without being crazy like this guy and driving my eyes absolutely insane. Again, anytime you see yourself doing and 16, and 17, and 17, if, blah, blah, else if, you're probably not dry, you're probably repeating yourself. There's probably an easier way to get it done. There's nothing wrong with this. If you do it this way, that's fine. But this is a little bit cleaner, I guess, or a little bit slicker. And it might be too clever. But hey, it's a late Sunday night. Why the heck not, right? Okay, so if you have any questions, feel free to ask us. This is most of what's happening in 3.02 as well. We've got our own user-defined function. Remember, there are two things going on. We're calling the random int function from the random library. That means we have to import it. Down here, this is our call. This is our assignment. Our parameters are 0 and 1. That means we want a random int that's either 0 or 1. If we wanted to do this for an 8-ball, and there were 20, all right, 0 is 1, and there are 19 after that, 19 plus the 0th, there are 20 different options. Then we would need 20 options in here too, right? And then we're all the way ready to go. Does that make sense? Okay, cool. I think that's it. I believe Brian will be back with a more exciting video for you later this week. Wish you guys all the best. If you have any questions, you can send them to your teacher and she can send them to us, or you can catch one of us at one of the online meetings later. Good luck and thanks.